Dear students, welcome to the Cryptography and Network Security subject. In this session, we are going to learn about RSA algorithm. RSA. So, RSA stands for Rivest, Shamir, and Adleman. So, these were the three scientists who proposed RSA, which is the first practical and mostly wide used public key crypto system. And they proposed this in the year 1977. So RSA is an asymmetric cryptographic algorithm. When we talk about asymmetric cryptography, which means that here we are dealing with two different keys. One is public key, and the other one is private key. Right. So what we are going to do here is we are going to make use of public key, which is accessible to everyone, and this key is used for encryption, or we can say it as verification purpose. And the other key, which is called as private key, so as the name itself indicates, so this key will be kept secret and it is not revealed to anyone. So this key we are making use of it for decryption or signing purpose. So how secure this RSA algorithm is? So in order, if I want to talk about the security of this RSA algorithm, basically, that security relies heavily on the mathematical difficulty that exists in factoring the large number. So, in the algorithm, we are going to look what exactly this is, right? So, we will be taking two prime numbers, right? And then we are going to constitute a value called as n. So, an adversary who is having this value n, it depends on how much difficulty that he has to face to break that n into two prime numbers. So that is what the security of the RSA depends upon. Basically, why RSA algorithm will be used? It is used for encryption purpose. It is used in the digital signature, as well as it is used in the secure key exchange. So when it comes to the different stages that is present in RSA algorithm, we generally say there are three stages. One is the first step is key generation, where your the public key and the private key will be generated, and the next step is about encryption, and then we have decryption. Right. So these are the three stages which RSA undergoes to perform the encryption and decryption. Now, when I say key generation, so here, as I told earlier, your public key and private key will be generated. To generate this, we are going to make use of large prime numbers. However, as an example, when we are considering an example to solve RSA, we don't generally consider large prime number. However, in practical, we are going to consider very large prime numbers. And as you know about encryption and decryption, so the process of converting the plain text into the ciphertext, that comes under encryption, and the process of recovering back that original plain text from the obtained ciphertext, we call it as decryption. The thing here is we are going to make use of two different keys for this two different purpose. So as we are making use of asymmetric cryptography, we'll make use of public key for encryption, and we are making use of private key for decryption. Let's see what are the steps involved in RSA algorithm. The first one is key generation. Now, how exactly key is generated? That is what we are going to see in this particular step. First, we have to select P and Q. As told, this P and Q are very large prime numbers. They should be prime number, both should be prime number, but they should be very large. Once P and Q is identified, I am going to calculate N. So N here it is used for modular operation. To perform the modular arithmetic, we are going to make use of this n. Once that n is calculated, how actually n is calculated? N is nothing but the product of two large prime numbers that we have taken. Now, once n is calculated, next we are going to calculate phi of n. So, this phi of n, it is nothing but the Euler's quotient. Guys, you might be remembering what is Euler's quotient, which I had taught you in the initial classes of this particular subject, right? So, here Euler's quotient is calculated by just performing p minus 1 multiplied by q minus 1. And then we are going to select an integer e. So this is where our key generation actually begins. So what is this e? So how e is calculated? E is nothing but when I consider e along with phi of n, they both should be co-prime. They both should be co-prime to each other. When we say co-prime, you know that the GCD of those two numbers should be 1, or the highest common factor should be 1, right? And once E is calculated, I obtain my public key. So what is my public key? My public key is nothing but combination of E and N. So once that is done, as a next process, I'm going to calculate D. So generally, we are going to make use of the modular operation of this sort to find D. So to simplify our process, what we are going to do is we are going to find inverse of E, and that inverse of E itself will give us the D value. We are going to calculate the inverse of E. Now, how to calculate this inverse also I have taught you, right? So hope you're remembering it. Else just go back, refer your notes, so you'll be able to easily understand, right? And once D is calculated, guys, now we got our private key. So what is that private key? Private key is nothing but the combination of D and N. So your public key is combination of E and N, and private key is combination of D and N. So this is what is your key generation step. Once this step is done, we have the private key and the public key with us. The next is about encryption and decryption. So let us consider there is a message M, and this message M, generally here we are going to consider it as a numeric value. Fine, this will be a numeric value, and this value, it should be less than n. How did you get this n? As you know, by multiplying the sufficiently large prime numbers p and q. Now once we have this message, my task is now to create the ciphertext. Now how do I get ciphertext? By encrypting the message. How will I encrypt? That is what is the question here. So what we do is, see, remember, my public key is combination of E and N, right? So how to remember this, sir? Whether I will be using E and N or I will be using D and N. So how to remember this? What you can do is, guys, so you remember this E, right? E. You have to find anyways E, right? So let's consider that this E stands for encryption. So by this way, you can, make up your mind that for encryption purpose, we're going to make use of E. And similar lines, I can say that for decryption purpose, we're going to make use of D. That we'll see next. So what is this ciphertext? Ciphertext is nothing but message to the power E mod N. So as you can see here, we have used the combination of the E and N. Combination of E and N is used, which is nothing but our public key. So whose public key is? So to be frank, this should be public key of the receiver, right? Yes. Now once the ciphertext is done, now next task is to get it back. That is, I want to get my plain text back. So what should I do? I'll be giving input C as the input to my decryption algorithm. What is that C? C is nothing but the ciphertext. So what the algorithm is going to give? It is going to give us the actual message. But how? So what it is actually doing? So it is taking C, that is ciphertext, raising it to the power D, which is nothing but the decryption key, and then we are going to take mod n. So you can easily observe here, like how we had for encryption, here also we have combination of D and N, which is nothing but my private key, right? Private key of whom? Private key of the receiver. So this is how encryption and decryption is performed in or using RSA algorithm. Now let's see an example. So in this example, we have given with two prime numbers. One is 11 and the other one is 3, right? So is it sufficiently large? Obviously no, right? So it's not large prime number. As I told, it will be infeasible if I'll be considering large prime numbers. It takes more time for us. So as an example, let's consider the small example where P is 11 and Q is 3. Let's consider this message to be equal to 9. Okay, here message is not given. Generally message will be given. If not given, you have to assume it. Even the prime numbers. Sir, can I consider 3 and 5? Yes, obviously, because both are prime numbers. You can consider and proceed. Fine. Now, let's start with the first step. So, what is that first step? First step is about key generation, right? First step is about key generation. So, in this first step of key generation, what basically we have to do? We have to create private key and public key, correct? So before that, what we have to do? We have to first find n. First find n. Now how do I find this n? N is nothing but, we know it, it is nothing but p into q. Now what is that p into q? What is that n? In this case it will be 11 into 3, which is equals to 33. So n value in this case is 33. Now, once I do that, the next step is I have to find Euler's quotient of n. Now, what this is, so Euler's quotient of n is nothing but your p minus 1 multiplied by q minus 1. So, as you can see it, p minus 1 would be 10 minus 1, which is, sorry, 11 minus 1, which is 10, and q is nothing but 3 minus 1, which is 2. So, basically, I say pi of n will be equal to 20. Pi of n will be equal to 20. Now once pi of n is done, the next task of us is to find the e. Right? Because without e I cannot get public key, and without d I cannot get private key. So what I'm going to do is I'm going to calculate e. Now e should be calculated such that when you take the GCD of e and that pi of n whatever we have, so this value should be equal to 1, right? So now we have phi of n as 20, right? Pi of n is 20. Let's start taking the value of e. E is equals to 1. So e1, we need not consider 1 because 1 becomes the universal fact. And then let's say 2. Now when I say 2, I'm talking about the GCD of 2 and 20. It's not equal to 1. When I consider e value equal to 3, is the GCD of 3 and 20 is 1? Obviously, yes. So you got your E. Therefore, what is E? E is nothing but 3. Right? Once E is calculated, next I can write my public key. So whatever is their public key, so which is the combination of what? Public key is combination of E and D. Okay, sorry, E and N. N is 33. So 3 and 33 is my public key now. Fine. So similarly, I have to find private key also. So what I should do for finding private key, I need to first find D. Now what is this D? So as per the algorithm, D should be congruent to E mod pi of n. E mod pi of n. Right. Now otherwise, this can also be written as D E congruent to 1 mod pi of n. Fine. Now, how do you calculate this? Because we know the value of E. So, since we know the value of E, right? So, what we will do? We will write it as 3 into D, right? 3 into D congruent to 1 mod 20. Now, the task here is to find different values of D such that which when multiplied with 3 and divided by 20 would give you a remainder 1. So which means, so I have to try with 1, no, not possible, 2 not possible, 3 not possible, 4 not possible, 5 not possible, 6 not possible, 7, yes, 7 is possible. Therefore, what is the value of D? D value is nothing but 7. So once I calculated D, obviously my private key will be taken. Private key is calculated. What is the private key? Private key is nothing but D, comma N. What is that N? N is nothing but 33. Right? This is my private key. Now what I will be doing, I have to perform encryption and decryption. So how do we do that encryption and decryption? How do we perform that encryption and decryption? So encryption, right? So for this, what we require, right? So encryption is nothing but ciphertext, which is nothing but message power E, and you have mod N. So now in this case, message we have considered it as 9, right? E obtained is 3, and then we have this mod 33. 9 power 3 mod 33. Why is it 9 power 3? Because M value is 9, right? So what is it? How to calculate now? So we have to calculate the value of 9 power 3. So what would be 9 power 3? 9 power 3 would be 729, right? 729 mod 33 is what I have to do. So when I do 729 mod 33, so what is that I'm going to get? Let's check that. So what is that I'm going to get? So I'm going to get 3. I'm going to get 3 here. Right? Ciphertext is 3. Now I have got my ciphertext. I have got my ciphertext. I have to go with decryption process. So just write what is decryption. In decryption, we are going to get the plain text. How? Ciphertext power D mod N. What is ciphertext? 3, 3 power 3 mod 33. Right? So D is what? D is 7 actually, right? Sorry, D is 7, not 3, D is 7. Now calculate this. So you have to calculate 3 power 7, which is nothing but 2187, right? So it is 2187 mod 33. Now when you calculate the mod of this, what is that you are going to get, right? So we are going to get 9 here. We are going to get 9. Did we get back the original message, plain text? Yes. So this is about your RSA algorithm. So it involves 3 steps: key generation, where we are going to generate the public key and the private key. Once that is generated, you are going to perform the encryption, and then you are going to get the ciphertext. Use that ciphertext to obtain the decryption. Right? Thank you.